Hello, my name is Orestes Radimus and I'm doing the first lab charts tapes for the course of Physics 2212. So for the first experiment, we wanted to determine the amount of excess charge on a tape, and what we did was placing one tape on top of another one and then abstractly separating them so that charge would be created on both tapes. So we investigated the interactions between two tapes, and as they came into contact, they repelled each other, as of course they had the same charge. And when the U tape came into contact with neutral objects, books, or other objects, they attracted each other. But this didn't help us at all determining if it's positive or negative charge, the U tape. So we rubbed the plastic pen, and then the pen acquired negative charge, and as we saw, the U-tape attracted the pen. Therefore, the U-tape has a positive sign of charge. So in case the U-tape had a negative charge, it would definitely repel the plastic pen, and the neutral U-tape, we have no interaction with the charged plastic pen. For the experiment 2, we set up two U-tapes again, and the B U-tape was set up on two objects, and we saw the interactions between the two of them, and we wanted to determine the forces exerted on the tapes at the measured distance apart, and more specifically for the interactions for tape B. So we saw that on tape 2 there are two forces, the F electric force and the gravitational force to be exact. So since the momentum of tape is not changing and the net y component is zero, is zero because of the second law of Newton. And so the two objects that exert vertical forces on tape B are the Earth due to the gravitational force and the tape A exerting the electrical force on tape B. And so we did various calculations. We used the linear density and the law of the three so we can find the mass of the tape. And using the length of the tape, which was 0.2 meters, and the linear density is 1 gram per meter. So for 1 gram for 1 meter, x, we wanted the mass we want to find for 0.2 meters as we measured. And so using the law of the three, we get that the mass is 0.2 grams, and we need to convert that mass into kilograms so that we go and use the gravitational force, the equation, which is mass times g, with the g that we all know 9.81 meters per second to the power of 2, and then we got the number 1.962 times 10 to the power of negative 6 Newton, of course. And we made two assumptions. The assumption that each U-tape has the same net charge because the tapes have the same material and dimensions, and of course they were charged the same way. And we also assumed that each tape has all of its charge locating at a single point at the center of the tape. And then we did more calculations. So the electric force, of course, equals, it's the exact, they have the same magnitude, but the opposite direction. And we know the constants, the electrical force, and the 1/4 times pi epsilon O. And the distance we measured before the tape B begins to flow was 0.025 meters. And so using the electrical force equation from Coulomb's law, we solve for Q, and then we get 11.65 Coulomb. And then we continue to find the number of electrons, which is the ratio of the charge over the charge of the electron, and we got that the number of electrons is 7.29 times 10 to the power of negative 19, and then knowing the well-known dimensions, the length of the tape, the length dimension that was given to us, the width of the tape that we measured, and we find the area of the tape, which is the length times width, and they got this number. And from the number of atoms on the sticky surface, we need to do the ratio of the length of the tape over the dimension, and then do the same with the width, and then multiply both results so we can get the number of atoms on a sticky surface. To explain this better, I made this shape. So we see here the two atoms, the distance of the centers between them, and the dimension of one atom. And so we assume that the distance between the centers of the two atoms were the same number with twice the radius of one atom, which of course is diameter. And we also found the ratio of the number of electrons to the number of atoms on the sticky surface, and we got the number 0.28. And so two questions were raised also. What if the electrons had positive charge and protons had negative charge? What would change? So basically, the forces would still be attractive on each occasion. For example, when different signs, or if there are neutral objects with charged objects, the still force would be attractive, and so as the repellent forces, those objects that have the same sign, like the same charge, they would still have repellent forces. And why is important to handle the charge tapes as little as possible? What will happen with the charge tapes? So basically, when we touch the tapes, the tape gradually loses its charge, and eventually it will become neutral as it will become neutral when we touch it. We use the glow script to do the computations, the various constants, and we use two scale factors in order to become visible, and the linear density, all these constants we talked before. And after that, the fractions from lab 0 and the initial values, we did the calculations, the mass of the tape using the law of the three as we talked about it, and the linear density, and then the gravitational force, the electrical force, and we also calculated the charge, and then added the two objects, the upper tape and the bottom tape, the upper tape with blue color and the bottom tape with green. And then we added the arrows using, in both occasions, scale factors so that we can actually see them. And here's the glow script visualization. Here is the tape B, the electrical force on top, and then below the gravitational force. And we see here the data with the numbers, the gravitational force in Newton, the charge, and the number of electrons. Thank you very much for your attention.